So for example, of the sampling used to answer the research question about the population, here you can find in your textbook. The example one is members of the political party in the Texas. So now people are very excited about the election. But if the political party, they would like to know the estimation of the proportion of the registered voters in the state who may favor the candidate, or how many votes they can win. So they will use a sample of 400 registered voters in the Texas are selected, and 160 of them, of the sample voters, they can indicate a preference from the candidate. So it's an estimate of the portion of the population of the registered voters that favoring the candidate. So we can use the sample is 400, but from our sample we know there are 160 persons, they are in favor of the candidate the political party recommended. So the portion is about 0.40. So they can use such a result to indicate that they may win 40 percentage supporting from this state. And the sample 2 is a tire manufacturer that is considering producing a new tire designed to provide an increase in lifetime distance of the first current time or current line of the tire. So in order to estimate the mean useful life of the new tires, the manufacturer, they will to produce a sample of 120 tires for the testing. And from the testing, that would provide a sample mean of 50,800 kilometers. So it's an estimate of the mean useful life for the population of the new tires that was 58,400 kilometers. And so from the examples, we can do a summary. That is, sample can result provide only the estimate of the value of the corresponding population characteristics. We do not expect the exactly result because we just select some portion from our sampling. And our sampling is just on behalf some parts of our population. So the sample contains only a portion of the population, and some sampling error is to be expected. And with the proper sampling method, the sample result will provide a good estimate of the population parameters. And the sample population is the population from which the sample is drawn. For example, the all registered voters in Texas, or all the tires that could have been made by the production process at a particular point in time. And we would use a frame that to make the boundary of our sample for, that we can select it from our population. For example, a list of all the registered voters. So it's the introduction about the sample and the sampling. Now let's continue to introduce some problem and to let you know the different sampling and how to estimate it. This is a sample. This is an example questions from our textbook, and it's about the electronic association. And from the electronic associate INC, it has been assigned the task of developing a profile of the company's 2,500 managers. The characteristics to be identified include the mean annual salary for the manager and the proportion of the manager have completed the company's management training program. So it would be very easy for you if you have 2,500 managers' profile and information. And through the information from our textbook, we can know the population mean is around 780,000, and the population standard deviation is 4,000. And the data for the training program status show that there is 1,500 of the 2,500 managers they has complete the training program. So if we let P denote the proportion of the population that completed the training program, it would use 1,500 divided by the sampling or the all population, that is 2,500. So you will know the proportion who completed the training program is about 0.60. But there will be a question, that is, if today we cannot obtain all the manager's profile or information, we only can estimate by a sampling way or by using a sample of the managers. How could we do it to estimate it? So it would be a question from a sampling from a finite population. A finite population are often defined as by the list, such as the organization membership roster, credit card account numbers, inventory product numbers. And just like the example from the electronic associate INC, you will find they has the total manager numbers that is 2,500. So it's a finite population. And the simplest type of the probability sample is one in which each sample size n has the same probability of being selected. So it's called a simple random sample. So today, a simple random sample of the size n for a finite population of the size n is a sample selected such that each possible sample of the size n has the same probability of being selected. So one procedure for selecting a simple random sample from a finite population is to use a table of the random number to choose the elements from the sample one at a time, and in which each of the elements can remain in the population has the same probability of being selected. So you can find in your textbook is on the page 323. There is a random numbers table, and then you can choose 4 digits from it to be the number of the number ID you would like to select it from all the 2,500 managers. For example, the first one you can choose will be the number ID is 36327, and the second one could be 1599, and the third one could be 8671. And the fourth one you could choose is 7445, and etc. Then, from a sampling from a finite population, the sampling they could have 2 possible ways you need to consider. One is the sampling without the placement, and the other is sampling with the placement. And if we choose it without the placement, that means we do not want to select a sample that more than one time. Any previous used random number are ignored. So replacing each sample element before selecting the subsequent element is called sampling with replacement. That is, we will select a sample that the previous has been used, and then we still use it. And that means an element can appear in the sample more than one time. So in a large sampling project, computer-generated the random number are often used to automate the sample selection process. And when we refer to a simple random sampling, we will assume the sampling is without the replacement. And the other we would like to introduce will be an infinite population. So in the infinite population, sometimes we want to select a sample, but we will find it's not possible to obtain a list of all the elements in the population. So in the result, we can construct a frame for the population. And in such condition, we cannot use a random number to select our population. And in such situation, we call it the infinite population. In such case, we must select a random sample in order to make the valid statistic inferences about the population from which sample is taken. So usually, in order to select sample from an infinite population, we would like to make our condition can be satisfied. The first condition is each element selected comes from a population of interest, and the second is each element is selected independently. So in such condition, the population are often generated by an ongoing process. So there will be no upper limit for the number of the units we can generate. So in such condition, some example can be used for the ongoing process with an infinite population, such as the parts being manufactured on a production line, because we cannot develop a list of all the elements that could be produced, so the population is considered infinite. And the second is transaction occur at a bank. For example, the customer arrival process is ongoing, and there is no way to obtain a list of all the customers in the population. Or the telephone calls arriving at a technical help desk, or the customer that entering a store.